Alright guys, welcome back. At this point you've all finished your second quiz on the trig proofs, and we are now going to talk about the last new thing that you need to learn for our unit, this trig proof unit. So the last piece are called double angle formulas. Now what I mean by double angle is where the angle itself, which we've been using x a lot of times, is doubled. So as you can see here, sine of 2 theta. So that's double the angle. Or over here, cosine of 2 theta. Now we only deal with the double angle formulas of sine and cosine, and that is because every other function, the secant, cosecant, tangent, and cotangent, can all be written in terms of sine and cosine if needed. So, the double angle of sine can only be written one way, and that is to have it be 2 times the sine of the angle, cosine of the angle. Cosine of a double angle can be written 3 different ways, and it's your choice as to which one you use. What you'll find is that the problem itself will call for one more than another, and so it's easier to make one of them work than something else. So, cosine of the double angle is going to be equal to cosine squared minus sine squared, or it's going to be equal to 1 minus 2 sine squared, or 2 cosine squared minus 1. So those are our 3 options for the cosine double angle. Again, we only have one option for the sine double angle. So we're going to go ahead and simplify a few of these by using those double angles. Alright, the first one is 2 sine to the 4th cosine to the 4th. Or, I apologize, 2 sine pi over 4 cosine pi over 4. So what you should be noticing here is that 1, there are no real double angles. It's not like it's a 2 theta that's in there right now. But what this does look like immediately in my mind is the sine double angle formula. So this looks very similar to where we had written above sine of 2 theta equals 2 sine of theta cosine theta. So what I'm going to do is condense this into this format. So this, because it's 2 sine cosine, becomes the sine of 2 times the angle, which is pi over 4. What is 2 times pi over 4? Well, 2 times pi over 4 is the sine of pi over 2. Now what you guys should realize is that then you're going straight back to your cosine sine chart. That's at 90, so the sine of 90 is 1. And that's your answer. So, moving on to the next one. Cosine squared and minus sine squared. That is one of the cosine double angles. It's actually the very first one at the top of the list. So, we're going to condense that down again to give us the cosine of double my angle. Now my angle here is pi. So really, I'm asking you guys what the cosine of 2 pi is. If you go back to your cosine sine chart at pi, you guys should have this one memorized. This is the 0 and the 2 pi. Cosine is 1 and sine is 0. So my answer is 1. Again, if you're having issues following or you have any questions, you can feel free to jot them down, and we'll go over all the stuff that you're watching videos on next class. So, moving on to number 3. You guys can feel free to pause this as needed to write stuff down. Now, this one doesn't really look like any of the ones before, except for the fact that where I have in my formulas a 2 and a 1, I now have a 4 and a 2. So what you should be noticing is that there's a GCF here. So pull out that GCF. And that's what you're left with. Now, this is a double angle formula. That double angle formula is the cosine double angle formula. So you've got the 2 out front, that comes down, so this is the cosine of 2. My angle is x. There's nothing to solve for here. So in this case, because I do not actually have an angle that is in degrees or in radians, that's my answer, 2 cosine 2x. this one, looking through the ones at the top, you should notice this is again a cosine double angle formula. So this is going to condense down to give you the cosine of 2 times my angle, which is pi over 6. Now, the cosine of 2 pi over 6, 2 times pi over 6 reduces to pi over 3. Pi over 3 goes back to this triangle. This is a 1, this is a 2, this is a root 3, 30, 60. Over 3 means it's a 60. Cosine is adjacent over hypotenuse, so this is a 1 over a 2. And last but certainly not least, we have this one. Now again, notice no pi's, no degrees, so this is not going to have a number answer. You're still going to have sine or cosine involved. Cosine squared minus sine squared is the first cosine double angle. So what you're going to have is cosine of 2 times 2x, because that's what my angle is in each one. 2 times 2x should then give you 4x, which is your answer, cosine of 4x. Alright, so this top section has just been condensing each one, trying to get as close to a single answer as we could using our double angle formulas. Now you do have to know these. The bottom 4 are all dealing with proving them. So if you look at number 6, it says cosine to the 4th minus sine to the 4th equals cosine of 2x. So the first thing you need to realize is that that is a difference of squares. So much like we would before, if you had like an x squared minus 4, you would say, oh, that's x plus 2, x minus 2. We can do the same thing on this side. It's going to be cosine squared plus sine squared, and then cosine squared minus sine squared. Again, this side just comes down. Now, from this, that's 1. Cosine squared plus sine squared is 1. And that is the cosine double angle formula. So then from there, you just have that your cosine of 2x is equal to the cosine of 2x, and you're finished with your proof. All right, 3 more, guys, and then you guys are going to be cut loose to do your homework. So for number 7. Obviously, the double angle formula is the one that we're not going to mess with, so I'm going to go ahead and just draw my straight line down from there. The other side is the one we're going to work with. Now, if you'll remember what we have at the top, everything is in terms of sine and cosine. So that's the first thing you need to do, is get everything in terms of sine and cosine. So this is going to become 1 over sine squared minus 2 over 1 over sine squared. Now, we're right back to that mess of a fraction within a fraction. We don't like it. So we multiply everything by the denominators. That's going to cause this first one to become a 1, and this second one to become minus 2 sine squared x. And then the bottom cancels, and you just have a 1. So then with that being said, this is a cosine double angle formula. So you end up with cosine of 2x and cosine of 2x. We only need to see it as the over 1. There's the over 1. All right, for number 8, you have the secant double angle formula. Now, I don't know about you guys, but we don't have a double angle formula for secant. Well, what you guys should recognize is that secant is just 1 over cosine. So my end game here, my end goal for this problem is to end up with a 1 over cosine double angle. If we can do that, then we have our solution as needed. So, first thing we're going to do is convert everything into sines and cosines. So this side's going to come down. This is going to be cosine x over sine x plus sine x over cosine x all over cosine x over sine x minus sine x over cosine x. So now, in order to keep ourselves straight, we're going to get rid of all of those fractions within fractions by multiplying everything by sine and cosine on top and bottom. So, from there, the sines cancel, so I'm left with cosine squared x. And then over here, the cosines cancel, so I'm left with sine squared x. And that's nice because we know that's going to end up going to 1. And on the bottom, the sines cancel, so I have cosine squared x minus the cosines cancel, so sine squared x. And that's going to leave me with 1 over cosine squared x minus sine squared x. And what you should see there is that that is the very first of your double angles for cosine. So 1 over the cosine double angle is the same as the secant double angle. And that is your final answer on that problem. Again, go back, pause, rewind, do whatever you need to do in order to make this make sense for you. But I'm trying to get through it quickly because I've got somebody waiting to come in and clean my room. So, with that being said, for number 9. Hi.
How about you?
Doing all right. I'm actually recording the lesson. Or not. All right, guys, I'm going to have to pause and take this back up in a little bit.